Linux Technologies will be releasing a new version of SIMAC in the summer of 2022. In this video, I'd like to show you some of the new features. SIMAC version 2 has an electron beam model with more details around some LINAC components such as the modulator and electron gun. It also has some links which allows you to go from the simulator to the core space more easily. We can see some of the features in this view, which shows a standing wave accelerator. I have a 6 MV mode selected, and I can switch to the 18 MV mode by clicking here and then submitting. One of the new features in SIMAC is the energy switch, which is used in the standing wave machine. In the 18 MV mode, we don't use the energy switch, which is shown here. However, if we activate it, it will change the energy of the beam. I can activate it by clicking this button over here and clicking Submit. And we see that the energy of the beam has changed from 18 MeV to 13.33 MeV. A second feature of SIMAC version 2 is a more direct link between the simulator and the core space. When I hover over the components, you see a box highlighted that shows the component that is in focus. When I click on the component, you get a menu that says what the component is and gives a link to the core space where the component is explained. So here I have chosen the energy switch, and if I click on the link to learn more, this brings me to the core space and shows the section where the energy switch is explained. You can read about the energy switch here and then go back to the simulator by pressing the browser's back button. Apart from the klystron-based standing wave accelerator like we have here, SIMAC version 2 also has a model for a magnetron-based traveling wave accelerator, which I can show you here. This screen functions in the same way as the standing wave-based accelerator, but with components for this style of accelerator, such as the traveling wave accelerator with the RF feedback, and the magnetron, and the diode gun. SIMAC version 2 also has a detailed model of the modulator, which we see here. It shows the charging and discharging of the PFN. Here we see the discharging pulse over here, and the individual voltages of the PFN capacitors, creating its discharge pattern over here. For the klystron modulator, we see the charging cycle on the left and the discharging cycle on the right. The plots also have zooming features, which allows you to zoom in on certain parts of the plot. The standing wave accelerator modulator also shows the RF reflected pulse over here, showing the relationship between the RF power and the gun current. Other improvements to SIMAC version 2 are the gun model, which has details of the triode and diode gun. We can control the gun high voltage, filament voltage, and grid voltage over here. And our gun model shows the gun operating points in relationship to the space charge and temperature limited modes. And we also have a model for a diode gun, which is used with a traveling wave-based machine. SIMAC version 2 will have a much improved photon beam model than the original version of SIMAC. Our new beam model shows a depth of curve with correct Dmax as well as field size dependence on the PDD, and the new version of SIMAC will also offer realistic profiles which correctly show the dose as a function of field size. We will integrate these beam models into our simulator and add an improved steering model, which will have an improved model for both the standing wave and traveling wave styles of accelerator. SIMAC version 2 will be released in the summer of 2022 with these improved features. With this new version, you should be able to set up some specific components of the accelerator and see the effects on the photon beam. This new version of SIMAC will be the basis for our new digital radiotherapy platform. Our plan for SIMAC is to develop an advanced radiotherapy digital platform which can be used to help in LINAC maintenance, quality assurance, and eventually treatment planning. SIMAC version 2 is our starting point. We hope you'll enjoy it.